Welcome, my friends, to our discussion of stoichiometry. So this will help us predict the mass of reactants and products as we go through stuff. So let's get started. Let's consider, first of all, this reaction of butane. This CH4H10 here is butane. It's going to be burned in the presence of oxygen, right here. And that's going to give us carbon dioxide and water. And we can see from our balanced equation that to make this reaction happen, we need at least 2 of these and 13 oxygens. And if we have 2 butanes and 13 oxygens, we're going to make 8 carbon dioxides and 10 waters. Now, an important thing to note here is that these numbers out in front, the 2, the 13, the 8, and the 10, are not having, I don't have anything to do with how heavy they are, but rather how many they are. For that reason, our chemical equations, the only thing we care about in chemistry is how many particles we have, not how heavy each particle is. But of course, counting out particles in chemistry is really hard. It's super small. So we have to work with these how heavy numbers. But our first step when we have a how heavy number, like a gram number, is to convert them into how many so we can use this equation. This equation is what tells us how many of each thing we need to make this whole thing work. All right, so now we want to solve, we're going to figure out, we have 13.56 grams of butane in our lighter, and we're trying to figure out, well, how much oxygen do we need to make that, to use up all that butane? Well, gosh, we know we need 13 of them for every 2, but we got to first figure out how many butanes we have, because this is how heavy they are. So let's start with that first. So the first thing we're going to do is start with 13.56 grams of butane, and here I'm going to go C4H10. And then over here, my handwriting's a little sloppy, bear with me. We're going to go with the molar mass of butane. So to convert from grams to moles, I need to know how much 1 mole weighs. And to find that, I look on the periodic table. So I know that carbon is 12.01. So 12.01 times, I have 4 carbons, times 4, plus 1.008 for the mass of hydrogen, times 10, because I have 10 of those. So 1 mole of butane has a mass of 58.2 grams. 12 grams, and that is 1 mole of C4H10, and this is C4H10 as well. So now I have right here, these cancel out. So what this number tells me, this first step, what this tells me is the number of moles of butane, C4H10, in 13.56 grams of butane, C4H10, right? So I haven't changed anything. I just converted from grams to moles. This is the how many number. Now I know once I do this, I get the how many number. I can say, okay, for every 2 of these, I need 13 of these. So here I'm going to put the 2 moles of butane, C4H10. And the reason I put that on bottom is because I need the moles of butane to cancel with the moles of butane. So I know whatever's up here has to go down below in the next fraction. Same thing here, grams of butane, grams of butane. And then I go here, okay, so I'm going to moles of oxygen. So I'm going to do, I want 13 moles of O2. Whoops. So moles of O2 is 13 to 2 ratio, and that's my next step. All right, so right now I have moles of butane canceling with moles of butane. This right here, this step, all 3 of these together, all the way over like this. So step 2, this tells me the number, if I were to stop and do the math now, if I were to do all the math right now, this would be the number of moles of O2 needed, ooh, this is getting terrible, to use up all 13.56 6 grams of the butane. So C4H10. Sorry, the pen's not keeping up with me all of a sudden. But so here's the key. This tells me how many oxygens I need to use up all of this 13.56 of butane. It doesn't tell me how heavy. Now, at this point, I know how many oxygens, but I can't go count them with a tweezer. So I need to convert this how many number into a how heavy number, because that's something I can measure in the lab. So my next step then is to take this how many number and convert it to how heavy. And for that, I need the molar mass of O2. And each oxygen is 16 grams per mole, so 32 together. Now I notice here that moles of O2 are on top, so I know the 1 mole of O2 goes on bottom. And over here is the 32 grams of O2. And this number came straight from the periodic table. So O2 is, each oxygen is 16, 32. Now in the end, so now moles of O2 cancel. Moles of O2 cancel. All of these steps, all three of them together. This is the number of grams of O2 needed to use up all the propane. So needed, well, I'm not going to keep writing. So you have to just write it down from what I said. So this is the number of grams of O2 needed to use up all 13.56 grams of butane. And to do the math, all we do is we start with this number, 13.56 in our calculator. And the next number is on bottom, so we divide. We divide here by 58.12 times 13, because it's on top. The 2's on bottom, so we do divided by 2. Times 13. Let me go back a step. One minute, mistake. 13 divided by 2. And then the last number's on top, so we hit multiply. Times 32. And that gives us an answer of 48.5. 48.53 grams. Again, this is the number of grams of O2 you need to use up 13.56 of butane. Or you could say another way. You could say, I need 48.53 grams of oxygen in order to burn 13.56 of butane. If I don't have this much, I can't burn that much. That's the meaning of that number. All right, so you should be able to set this problem up straight to finish. 1, 2, 3 steps from grams to moles of that same stuff, from moles of that stuff to moles of something new, and then from moles of that new thing to grams of that new thing. It'll always be that pattern for now. And then that'll give you the grams that you need of something to use up the first thing, or depending on what we're talking about in the equation. We'll do a few more together. All right, moving on to the next slide. So we have the exact same reaction, but this time we're asking not how much oxygen we need. We're asking how much CO2, how much CO2 we will produce. So right here, how much CO2 will we produce? This is what we're looking for this time. All right, so it starts out in a very similar way. I'm going to start with the 13.6 grams. And then here I'm going to convert that how heavy number into how many. And before we had our mass of butane as 58.12 grams per 1 mole. Well, that wasn't very cool. There we go. 58.12 grams per 1 mole. And this is, let me label some of this stuff. So this is butane, C4. I'm going to put a B for butane. just to make my life a little bit easier. So grams of butane cancel grams of butane. Now this number right here, this tells me the number of moles of butane in 13.56 grams of butane. All right, so far, so good. Now I need to go over here. Instead of going to oxygen, we're going to go to carbon dioxide. But notice I still need to cancel my moles of butane right here on top. So the next moles goes on bottom, and I go, okay, so for every 2 moles of butane, I get 8 moles of CO2. So 2 moles of butane over 8 moles of CO2. And again, I'm going to put this on the bottom because the moles of butane were here. The next mole to cancel has to be here of butane. So moles of butane, moles of butane. Now this number right here tells me, here's the cool thing. And notice how the language will change. Last time it was the number of moles of oxygen needed to use up, but we're not using the CO2, we're making it. So here's how we say this one. So this is the number of moles of CO2 that you make if you use up 13.56 grams of butane. So that's pretty cool. So this number, if we stopped here and we did the math, this would be the number of moles of CO2 that are made when you use up all 13.56 grams of butane. Now there's lots of ways to say this, but notice here how the language changed. It's when we're looking for a product as our answer, it's what we make if we use up what we started with. That's the kind of language we use. All right, so now this last step, again, we now know how many CO2s we need, but we can't count them with a tweezer. So we need to convert them to something we can measure in the lab, which would be grams. So here we would say that 1 mole, and again the moles go on bottom here because I see the mole on top, so the next one's got to go on bottom, of CO2 is to 44 grams of CO2. Now that molar mass is like 44.01 or something. So make sure you're using the correct molar mass. I'm being a little sloppy here. So moles of CO2 cancel moles of CO2. I'm left with just grams of CO2. Now to do this math, we again start with the 13.56. We do the next numbers on bottom, so we divide 58.12. And then we multiply because the 8's on top, so times 8 divided by 2. The 2's on bottom, so we divide. And the 44 is on top, so we multiply. Times 44. And that gives us a mass of 41.06 grams. And notice I started with 4 digits, so 1, 3, 5, 6, 4 digits. I'm going to end with 4 digits. They're called significant figures. I'm going to start with 4. I'm going to end with 4 of them. And this is the CO2. Now here's the killer. My pen's not working again. So this 41.06 grams, this is the mass of CO2 that you will make if you use up all 13.56 grams. That last statement is so key. All these statements here are how you show you understand stoichiometry. Anyone can set units up so they cancel. You can learn to do that. But then to actually understand what the number means, that's the real magic of it. That's really when you understand it well. So make sure you know that. You make 41.06 grams of CO2 when you burn 13.56 grams of butane. Awesome. So one last one. We'll do one more iteration of this. All right, this time we're going to say, hey, we need this much water. Whoops. Oh, not cool. There we go. This time we need, switch over real quick. We need to make this much water. So we're over here making water. And we're saying how much butane do we have to burn to make this much water? This is a terrible way to make water, but you could do it. I mean, you could literally just burn butane and let the gas cool and water would drip to the bottom. You'd be like, oh, I have water now. It's way easier to go to the sink instead of burning up your whole lighter for it. So let's find out how many grams of butane we need to make 56 grams of water. All right, so as before, we're going to start with the number we know, which in this case is 56.25 grams of H2O over 1. And we're going to simply convert this how heavy number into how many waters. So we're going to start with 18.016 grams of water is equal to 1 mole of water. And again, that number is you just add up the molar mass from the periodic table. And notice here I put grams on bottom so grams could cancel. And now the meaning of this first step. This is the number of moles of H2O in 56.25 grams of H2O. Pen's getting worse again. All right. So my next step, now that I know how many H2Os, I know that for every 10 H2Os I make, I've got to use up 2 of these. So on my next fraction, I'm going to put my moles of H2O on bottom because they're on top here. And that's 10 moles H2O. And on top, it's a terrible 10. And on top is going to be the 2 moles of butane. And again, I'm going to use B for butane because my pen doesn't like being able to do much. Now this number right here, this step, this is the number of moles of butane. Now notice how the language changes here. That we need to make 56.25 grams of water. Okay, so notice here we said because we're starting here and we're going there, we need this in order to make that. So our language of this description matches the equation that we're looking at. We're starting with a product. We got to have this much. We need to figure out how much we need of this to make that. So just keep your language consistent there. All right. Last step. Now, we know how many moles of water, but again, we can't count them with a tweezer, so we got to convert something measurable, which is grams. Butane. So now we need to convert with a molar mass of butane. We say, hey, 1 mole of butane. And I believe it was 58.12 grams. But if I was wrong on that, go ahead and put the right one in. But I'm going to go 58.12 grams of butane. Sorry about the handwriting. It's getting awful now. So moles of water cancel with moles of water. Moles of butane with moles of butane. I'm left here with the answer. And now to do this, we start with the first number as always, 56.25. The next number's on bottom, so we divide 18.01, 6. And the next number's on top, so we times 2. Then we divide by the 10, divided by 10. And then we times 58.12. And we end up with a mass of 36.3 grams of H2O. Oh, sorry, that's not true. Grams of butane. So if we wanted to make, and we should have 4 numbers there, sorry, 30.29 it should be. We started with 4 digits, we should end with 4 digits. So if we wanted to make 56.25 grams of water, we would have to burn 36.29 grams of butane. in order to make this much stuff. So again, you can see how that language has changed. All right, so I've taken you through 3 examples. Hopefully you're ready to rock and roll. And I apologize for the scrappiness of the writing. For whatever reason, the pen's not keeping up on the screen today. Awesome, good job.